Hi, everyone, and welcome to today's SQL Office Hours session. Today, we're going to be looking at an interesting topic, and that is the subject of null. Now, this is a problem that catches out, both the beginners and the more experienced among us as well, but is particularly a beginner problem. And that's where you're trying to search for rows that have the value null. You might run a query like this. You may have done this, or you very likely know someone else who has tried something like this only to get the result, nothing returned, right? So we're trying to find all the rows where the value is null and we get nothing back. So we think about this and we must go, well, if we change the query around and make it into a not equals, surely we're going to get all the rows back from the table, right? And we run the query and we get no rows selected still. It's like, hang on, what is going on here? How does this work? Because we're quite familiar with the kind of dual true binary logic, Boolean logic type approach, where things are either true or false. So if we search for things equal to a value and that returns no rows, then logically we're used to the concept of the inverting that, saying it's not equal to the value, returning all the rows in the table. Unfortunately, null breaks this considerably because it introduces a third state, that is that of unknown. So now we have three value logic and we can no longer work in the nice simple world that we had before. So just give a quick example of how this works. So we'll start off with basic true false logic. Like I say, this is something I think we all get fairly intuitively, even from a fairly young age. So we've got two values, they're both 1, and we ask if they're equal. Well, that's true. 1 is equal to 1, that's correct. If we do the same test, but have different values, so 1 and 99, for example, are they equal? No, that's not true, so it's false. Now, we might say, are those values not equal to each other? Well, that's true, right? 1 is not equal to 99, so that is true. And if they were the same, we would say that was false. However, if either of these values are null, then regardless of whether we say the values are equal to each other or not equal to each other, the result of this is still unknown, all right? And the problem here is in SQL, where clauses only return the rows that evaluate to true. If the result is unknown, we don't get those rows back in the database in the query. So the question here is, how do we actually find these rows? Well, the basic way is we need to use a new condition and we'll check that the column is null or is not null if we want values, the rows that actually have a non-null value. So we need to introduce this new condition to find the null valued rows. And this is just one of kind of many quirks, shall we say, or differences or subtleties in behavior of null, which break our usual understanding of how things might work. So a lot of people, particularly relational theorists, really dislike the concept of null and say, you should never use it, right? We won't store nulls in the database. And so we can avoid these kind of three value logic problems. So what we're going to do today is we'll look at some more of these kind of differences, inconsistencies that null can bring and the problems that might arise from them. And then having asked that, it's like, well, given all these issues, why do we even have null? So we'll look at that in a bit more detail. Then some ways that you can avoid having null in your database. And we'll wrap up by looking at some more ways that you can actually handle and deal with null, because fundamentally in modern relational databases, null is just a fact of life. So, hi everyone, I'm Chris Saxon. I'm part of Gerald Wenzel's developer advocate team and part of the answer team on Ask Tom. It's my job to help you get the best out of Oracle SQL and PL SQL, and hopefully have some fun whilst doing so. So with that in mind, as I say, we're going to jump into the details of how null works and see what we can do to mitigate or solve these kind of problems. And to start off with, actually, I'm just going to jump right into a demo showing some of the problems that can arise when you have to work with null values. Before I do that, I see someone's got a question. What is the rationale behind x not equal to null returning false? No, okay, so this is the thing here. When you say if something is not equal to null, it doesn't return false, it returns unknown. Okay, subtle difference, and where clauses only return rows that evaluate to true. X not equal to null is unknown. It is not true. Okay, so that is why it is not returned. It isn't false, it's unknown. I'll go one of the examples I've got a bit further on might make this a bit clearer, maybe, hopefully. So just stay with me as we work through these examples. All right, so start off with, so we want to find all the employees in the HR table that have got no commission. And the kind of basic way to think about it is you might go, well, if they're uncommissioned employees, they're not paid any commission at all, then their commission percentage would be 0, right? So let's run that query and we get no rows back, just kind of show no rows selected. So everyone gets commission, right? Well, no. Actually, we've just kind of got the problem I showed on the slides a couple of minutes ago. The thing here is the null values are buried in this column, so we can't actually see them. So a lot of times these kind of issues may not be quite as obvious as they first appear. So if we want to find everyone without commission, their commission isn't 0, we store null for it, we need to search for the rows where it is null. So we can see we get a whole bunch of people who don't have commission. So if you want to find the null valued rows, you have to find the ones where it is null. Now, there is an interesting consequence of this problem. Let's imagine we want to run another query. We want to find all the employees who do not manage a department. They are not departmental managers. So we might run a not in query like this, find everyone who's not set to be the manager of the department. So I'll run the query and again, we get no rows back here. And it's like, well, hang on. That sounds a bit fishy, right? If we think this means that everyone is then a manager of a department, that kind of doesn't sound right, right? Usually you're not going to have one person, a department per person. So let's just check and validate this. Is it really true that everyone is in fact a departmental manager? Well, we see there are, little over 100 rows in the employees table. And let's find all the managers for the departments. There's only 12 of them. Well, actually, there's only 11 of them, but one of those values is null. There are some departments which have not been assigned a manager for whatever reason. So that means in our not in query here, we are selecting null in this subquery. And effectively what happens, if we imagine we pull these values out, we've got the values from the departments table, the database is saying that these values are not equal, or employee ID is not equal to any of these values. So we say employee ID is not equal to null, and it's not equal to 108, so on and so forth. So the problem here is, as I said, something not equal to null evaluates to unknown, okay? And in order for and to be true, both of the input values must also be true. So we start here, we've got unknown and this one, let's say that's true. Unknown and true is, well, that's unknown, right? And then we add in the next condition and say unknown and true, that's also unknown, okay? So it doesn't matter what else we ever add here. If we keep adding more and clauses, the result will always be unknown because we've got this unknown criteria here. So we will never get any rows. So, okay, how do we fix this? How do we fix this not in problem? Well, one way is just to stop the null values being returned by the subquery. Just exclude them from the results like that. We do that, and then we can see we've got a whole bunch of rows in the table. Okay, so this is looking a bit more like it. This is what we would expect. There are a whole stack of employees who are not managers of a department. So this is one way to solve it. Another way, and the way I slightly prefer, is actually using not exists. Now, logically, these do the same thing. And as far as I'm aware, these days, from a performance perspective, they're basically the same. So why do I prefer not exists? Well, one of the goals of SQL was to make it like read like human language. And if we read this kind of query like a sentence, we're saying get all the employees where there is not a department where that person is its manager. I think not exist just kind of flows a bit more like, we can read it a bit more like a sentence than we can with not in. Plus, it automatically handles issues with nulls. We don't have to worry about adding this where is not null criteria as well. So that's my opinion on this. Ultimately, both of these methods work as long as you ensure you are handling nulls in these subqueries correctly. So that's just kind of one consequence of dealing with nulls, as we saw, and this really falls out of the fact that any comparisons equal to, not equal to, whatever, with null, return unknown. So, but there are other interesting consequences of this as well. Let's try counting rows in the table. So we got count star, that returns the number of rows in the group, and counting a column. Now this returns the number of non-null rows in the group. So we do that and we can see we get different values. We get all the rows, all the count star, but just the number of employees with a commission for the count of that column. So this has an impact on the results, but potentially what we do here can actually have some performance implications as well. So let's just take a look at the indexes on the employees table. So I'll just pin this. So we've got it. So we've got department ID, employee, and so on. We've got indexes on those columns. Now, if we do a count star, the database is able to use any of the indexes on mandatory columns, so columns with not null constraints on them. So we can see it's used the department index in this case. If we use count of a column, then and an optional column, there must be an index on that column. So let's just check manager ID. Let's check our query result. Manager ID, okay, there is a column and an index on that column. So we run the query, we find, yep, indeed, we do use that index. There isn't an index on commission, just double check. Yep, no indexes on commission there. So this can't use an index because it actually has to go to the table to read these values. So, what I'm doing there, I'm messing my query up. Let's actually run the query and get its plan. So there we go. We see we got a full scan of the employees table. So if it's an optional column, then there must be an index on that specific column for the optimizer to do an index scan rather than a full table scan. However, if we count all the rows, all the values for a mandatory column, so hire date, in this example, all employees must have a hire date, then actually the database can use any index on mandatory columns. So we see we've got that department index, it is used. That's because these values are all mandatory. So in effect, this returns the same as count star. So we're guaranteed to be able to use any index from on mandatory columns and get the correct result. So that means we don't need to create, or potentially we don't need to create a whole bunch of extra indexes on these things. Okay, so so not only can there be functional differences, there can be performance differences as well when you have or don't have nulls in your query. And this is just a simple example of that. There are more of them. So let's move on and look a bit further with some kind of aggregation. So we've got sums and averages. And notice these are kind of the same thing, these sums. One, I'm just taking the sum of the percentage, and the other I'm adding null to it. And the interesting question here is, what do we think? Do these return the same value, taking the sum of the commission percentage or the sum of the commission percentage plus null? Bear in mind that the commissions could be null themselves. What do we think? Anyone can be brave and take a stab as whether or not these two are going to return the same? Same for average. Will those two return the same? Will they give the same results, or will they give different results? It's interesting because sum, if we think about it, is just repeated addition. And here we're just adding some values with null. So yeah, so a couple of people straight in spotting that something plus null is always null, so they're going to return different results. If we run the query, we find that the basic sum and the basic average return the values that we expect. These are kind of null aware, I guess, is a way to specify it. They will discard, they will ignore null values. And a lot of the aggregate functions will do this. However, as Niels correctly says, when you add anything to null, the result is always null. And the same actually for other arithmetic operations, multiply, divide, subtract, and so on. They're going to return null as well. So the difference here is we've got something plus null, that's going to be null. We're averaging nulls, okay? So they do return different results in this case. However, there are some other subtle differences. There are some operators which don't return null, at least in Oracle database. One is concatenation. If we concatenate null to a string, then we still just get actually all the strings back, all the names. And this is probably partly a consequence of the fact that in Oracle database, the empty string, so just quotes with nothing in it, is considered null. So this is different to a lot of other relational databases. Many others do actually consider null and the empty string to be separate values and would also return null in the previous query. So this, there's a whole bunch of quirks and things that can be different when you use null, and some of them can be vendor specific as well. So let's move on, look at another example and difference between where clauses and check constraints. So here, what I'm going to try and do is insert a row, an employee with a negative salary. It's like something doesn't sound like a good idea, if I had a negative salary, I'd probably owe the company to work there. It's the kind of place I would never want to work. Okay, so let's try and run this. Hopefully the database isn't going to allow it, and fortunately it doesn't. There is a check constraint to prevent this. It's saying we're below the minimum salary for that we allow. So we check, we're trying to insert employee 99, we cannot insert them into the database. So cool, we can't insert negative salaries, but if we look at the condition for this check constraint, we'll see that there's actually a bit of a problem here, or a potential problem here. We don't allow negative values, but what about null values? Can we have employees with no salary? Well, let's just try that. Let's see, we're not assigning value to this null salary here. We'll run that. The query worked, or the block worked, the insert succeeded, we didn't get an error, and we have indeed inserted employee with a null salary. Interesting. And this is, again, another little difference between how check constraints and where clauses work. So the check constraint will only reject rows where this condition is false. If it is unknown, so the salary is null, it returns unknown and it allows it. So it doesn't reject it. But if we try and query it back again, we look for someone with that salary, because it's null, we don't get that row back. So interesting. We can have things which pass check constraints, but we can't actually necessarily query back again straight away. Something to look at very carefully when you are testing. So another subtlety and difference that can catch you out here. One final thing I want to cover, and that was just how nulls are sorted. So a default sort uses ascending, and that notionally, not really, but notionally means that nulls are greater than all other values. The nulls come at the end here. We start with the real values first. If we change that to a descending sort, then that follows the kind of logic we had. The nulls are greater, they're not really, but you can think of it that way. So they appear first and the real values are at the bottom, okay? So depending on which type of sort you use, depends on where those null values appear. Now, quite often, you probably don't want the null values at the top. If we're doing a descending sort in some kind of interactive report, we almost certainly want these to be at the bottom. Generally, we do. So you can control this explicitly with the nulls first or last clause. So we can see and actually force all those null values to appear at the bottom of our result set there. So that was just a few of the quirks and oddities that surround null. If there's any comments or questions on those, just let me know. I see there is a question that's come in. Is nullable is null or nullable equals valuable the same as nullable call equals valuable val or nullable call is null? It looks to me like you've just kind of switched the conditions around, made them either side of the or? If that's so, then yes, they're logically the same. I'm going to talk about that kind of thing a bit more towards the end of this session. So just keep that in mind. If you're still unclear, we can cover it, talk about it a bit later. Okay. All right. So I'm not seeing any other questions or comments come in at the moment. So let's move on. So we've seen there's lots of situations where null behaves in slightly unexpected or surprising ways, potentially. So at this point, you might be wondering, well, why do we have null? You know, if given it causes so many issues, why do we even bother to have it? Why does this exist? Well, the first thing to note is when you create a table, by default, all the columns are nullable. If you do not add the not null constraint, then null values are allowed in the table. And over time, if a constraint doesn't stop you inserting something, over time, the chance of there being null values inserted into this table pretty much approaches 100%. You know, there'll be a bug in the code, a script that shouldn't have been run, something like that, which inserts null values. So they can creep in to the database by accident. So, you know, what the defaults are can matter, and a lot of people will just go with the defaults and allow nullable columns. So you really want to stop and protect against this. So that's kind of that's not really a reason, is it? That's just more of an excuse. That kind of says why they might be more common than they really are. But why do we actually need null? What purpose does it serve? Well, when Ted Codd came up with the relational model, he identified two kind of reasons or use cases where you might need null values, things that you don't know. And generally speaking, you could say that they were either not applicable or missing information. And now there's various grays in terms of ways how you classify these, and you can further subdivide these into types of missing or not applicable information. So I'm just going to run through some examples of these and discuss ways that we can then avoid having to store null in those scenarios. So first up, let's imagine you're building like a hospital or doctor's surgery patient administration system, or an admin system for a hospital, that kind of thing. Now, as part of this, we're going to have to store details about lots of people, doctors and patients and staff, you know, staff and their patients. And because they're all people, there's going to be attributes they have in common. Everyone's, well, I say everyone, people have names, they've got dates of birth, they've got contact details, and so on. And those apply whether you are a patient or staff. However, there's a whole set of attributes which only apply if you're staff. Things like what your salary is, what your job title is, which department you're in, so on and so forth. Similarly, if you're a patient, there's a whole set of attributes which only apply if you're a patient. Things like if there's a hospital number identifier for you, what treatment you've had, when you were last admitted or last saw the doctor, that kind of thing. So there's attributes that are common, and there's some which only apply depending on whether you're a doctor or whether you're staff or whether you're a patient. And some people, you know, classic kind of, I'd say, beginner mistake with this scenario is kind of go, well, we've got stuff which applies to everyone and some things which only apply to some people, depending on who they are. So let's just create a giant person table or people table and store all this information here. So we've got a little asterisk to show that the attributes that are common to everyone are mandatory, their name, the birth date, and so on, but everything else is optional. Most people we record in the system will probably be patients, some will be staff, and even a small number could be patients and staff, all right? And the thing here is we've got kind of two sets of columns. If you are staff, we want to set your salary, your job title, etc. If you're a patient, we want to set your health care management information. And we want to set these as a group. If you're staff, they should all be not null, or they should all be null, depending on whether or not you're staff. Same applies for if you're a patient. So we can't just add basic not null constraints to do this. We have to do something funky to kind of check that either they're all not null, or they are either or they are all null, one or the other. It's a bit of a fiddle, bit of a faff, particularly if we've got lots of these columns. And this example's particularly interesting as well, because this is all kind of personal information, stuff that tends to be covered by data privacy regulations, things like GDPR. You know, if I work at a hospital and I need to be admitted as a patient for some reason, I don't want the doctors and nurses treating me to be able to look up my employment information, like how much I earn, that kind of thing. Similarly, once I've been discharged from hospital and well and back and work again, I don't want my my boss to be able to go in and just view my medical history. And the fact is, just by having these all this information in one giant table, someone runs a select star, they could query it all back. Now, we can do things like create views or use virtual private database to limit this, to reduce the chance of someone accidentally just querying back all my personal private information. But the fact is, it's still relatively easy to do just by accident. So we can actually solve both of these problems by splitting these into separate tables. We can have a table for staff and a table for patients. So now we can make all the staff-related attributes mandatory in the staff table and all the patient-related information mandatory in the patients table. So this is better, but you'll notice the stuff that's common to both people, like names, dates of birth, contacts, etc., we've duplicated it. We now got it in two separate tables. If we're back to the scenario, I both work at a hospital and I'm admitted for some reason, we've now got two separate records of my details, you know, my name and stuff. Verifying that those both do in fact apply to me and not to some other Chris Saxon who happens to be born on the same day is actually a really hard problem to solve, right? People do have the same name that were born on the same day, okay? And sometimes it's even been known to be born at the same place in the same hospital. So we actually need quite a lot of extra information to verify, are these the same person and so on. So this is better, but it doesn't really fully kind of solve, it introduces different problems, right? What I think you should do in these scenarios is we've actually got like a supertype subtype scenario here. The common attributes which apply to everyone should go in a generic personal people table, but we should have sub-child tables of that which hold the role-specific information, whether you're a patient or staff. This ensures we can make all the attributes mandatory where necessary, and it limits the chance, we avoid duplicating people's information, and it limits the chance of people accidentally querying patient information when they should be looking at staff and vice versa. So the key point here is quite often you might find a group of columns in a table, which either as a group should either be all not null or all null. In those scenarios, really, you should be splitting those into their own separate table. So that's one example. And this is the case where the attributes don't apply if you are not one or the other. Let's look at another example, and that is if issuing invoices. So a lot of companies will issue an invoice and get payment at a later date. Now, it's very common in kind of service industries. You know, I've got some workmen come to fix my windows or whatever. They'll give me the invoice and I'll pay it some point, they hope quite soon afterwards, right? So what we could do is have a single invoices table. And because the invoice might not be paid at the time of issuing, we record the paid date. If we have a paid date time column there, it has to be optional because there's always the chance I won't pay it until some point later. And in many businesses, that's actually the default mode of operation. People don't pay when the invoice is issued initially. So we've got the issue of here of having this null paid date time. And so what can we do here? Well, again, a solution, and possibly quite a good solution, would be to create a separate payments table. We should probably have a separate payments table anyway to record things like what the type of the payment was and the exactly when it was, and so on and so forth. But this also has a benefit because there could be multiple payments against an invoice. Maybe you pay a deposit first and then you pay the full balance later. Or maybe you pay half the balance in cash and half the balance on credit card or something like that. businesses might allow you to make multiple payments against an invoice, in which case having just a single paid date time, does that make sense? What does that date actually represent? First payment, the last payment, when it's fully paid? Yeah, it's a little bit ambiguous. So there's a lot of reasons why we might want to have a set, pull this out and pull a payments table anyway, but pulling that paid date time and effectively storing it there means we can avoid the issue of storing nulls there. So that's another example. Let's look another business related one, and that's of kind of like delivering goods or shipping goods. So it's quite common that, or reasonably common, that you might want to have some kind of delivery instructions for when you order stuff online. For example, if you're not in or you can't get to the door or whatever, you might want to tell, leave some instructions, leave this parcel with the neighbor, or maybe some other ones might say hide behind the plants or something like that. And the thing with this is it doesn't apply to all of us. It'll only apply to a small number of shipments, right? Not everyone has specific delivery instructions. Only a few of us will do. So we could create an orders table with our optional delivery instructions column. And I say that's nullable because not everyone will supply these. And in this instance, okay, we could create another table to store these, but actually, this is probably okay. Still not brilliant. We still allow nulls. But if we think about this, the delivery instructions, we're not going to be joining on it. We're not going to be doing things like sums or averages on it. We probably don't have many queries where this appears in the where clause, right? It's genuinely optional, and it forms little. It's going to be in the business logic of very few queries. It'll just be a column we select vast majority of times. So if you've got stuff which is rarely used and it's not used, like I say, in filtering, joining, aggregating queries, it's probably okay to make that optional. Things like comments, notes, etc., things which only apply in some circumstances. So in this case, it's not ideal, but still we could probably live with it because we're not going to have the worst issues that null brings. Okay, so we've looked at a few examples. Let's bring on another one, and this is one that's going to be really common, and that is storing people's address history. Okay, so when they moved into and moved out of each location. So one way we could do that is we could have a table and we store their start and end dates. Okay, so when start date's when they moved in, end date is when they moved out. Now, of course, where you currently live has no end date. It doesn't have an end date currently, but it will do at some point in the future. Ultimately, at some point, we're all going to move out. One way or another, we're all going to move out of where we currently live. Okay, so there is no end date for your current address at the moment. So one thing we could do is just say your current address is represented by the value null. It might also be set in the future. If we know we're going to move, so we can see this customer 2 has got an address that ends start of August, that's in the future, so that's where they currently live. So if we want to find all the current addresses for all the customers, we need to do a query like this. Because we've said null is the end date, or null end date means that is where they currently live. We need to write a query like this to pull that information out. And you see, the thing here is we've got to make sure we write this query correctly with respect to null handling. So how can we avoid nulls in this scenario? Well, one way is the approach we just kind of talked about, and that is to split the end dates into a separate table, right? We have the start dates in one table and a separate table storing the dates that they actually moved out of those tables. So this solves that null problem, but I'm not sure it makes our queries any easier, right? If we want to find all the current addresses, we need to find ones where the start date is in the past and there isn't a row in that customer addresses vacated table with an end date after today. So, we could do something like this, but I'm not sure this is the best way. I think probably the biggest drawback of this is it's kind of surprising. very common to have tables with start and end date columns on them, or need to record start and end date for various entities in your database. It is quite unusual to split that end date out into a separate table. If any of you have done this or work on a system that does do this, I'd love to hear it. So let us know in the comments if you've actually used something like this. So, I mean, we could do this to stop us storing nulls, or we could just make that end date mandatory. So we cannot store nulls in there. So how do we represent the current address then? Places where we haven't moved out yet, or we don't know when someone's going to move out. Well, we can store some dates in the far off future. For example, 31st of December, 1999, the highest possible date in Oracle database, and say, assume if we have that value for the end date, then that is a currently active row. I know, assuming the start date is in the past as well. It's not in the future. So the really nice thing about this is it makes our query to find the current addresses for the customers super easy. We just check that sysdate is between those start and end dates, something like this. So all good, we made our queries nice and simple, right? Well, okay, we might have made our most common query simple, find the current address or the address at a particular point in time super easy, but it doesn't make all queries easy. Let's look at a different one. Let's say you wanted to find, well, someone's asked you to find the last time someone moved out of an address. What is the maximum date that they moved out of each location? If we're using null end dates, or we're storing those in a separate table, so we're only providing a value when they have actually moved, or we know they've moved, we can do something like this. And max ignores those nulls, so we'll get those end dates. However, if we are using those, that kind of magic value, the 31st of December, we still need to exclude it from this query. So yes, we made some queries easier, but we haven't made all of them easier. And we've just kind of potentially introduced problems in other places. So at this point, I'm kind of interested, because I say storing start and end date columns on tables, I'm willing to bet most, if not all of you, have worked on a system that does this on at least some of your tables. So I'm really curious to see which of you, which you prefer, which of these methods that we've just discussed you actually like the best. So I've got a little poll. If you could just fill it in and let us know what's going on. I've seen there's been loads of comments flying through. I'll just see a few of these. Someone saying, why not NVL end date 31st of December? That's just a different way of handling or null, right? I mean, you could do that, but it's just a different method. What about temporal validity? That's a great question. You could use temporal validity. It's one way. It doesn't fully solve the problem, but it kind of does mask it, makes it easier for you in some cases. Okay, I think null is more easy to read or understand for newer devs. Yeah. What does what mean? Phyllis, what does what mean? Are you returning to temporal validity? It's a feature in Oracle database that allows you to more easily write these queries, these start and date type queries. I'm pretty sure I've had an office hours session on that in the past. So if you look it up, it's a way to simplify those types of queries that we did. Basically, you add some stuff to your database. Okay. Yeah, there's lots of people coming up with options like, how about a flag to show the active address? I mean, yeah, you could do things like that. There's various other ways to solve this problem. There's a problem when you need to ensure there's only one record with null for each entity. That's, yeah, a good point. An interesting thing about addresses is customers could have multiple addresses. So things like gaps and overlaps are in fact entirely possible with people's address history. I think pretty much every time I've moved, I've managed to have at least a few days overlap between me moving out of the old address, moving into the new location. So, but for other types of things, you need to strictly ensure, certainly there's no overlaps, potentially there's no gaps as well. Yeah, so, okay, so I think probably most of you have voted at this point, and if I just share the results, actually, Pretty much all of you are going for null end dates, so not storing anything rather than mandatory end dates. And before we kind of, a few of you actually gone for separate tables, so that's interesting. It was more of you than I expected. So say if you've got an example of you having done that, I'd love to hear it. So please share it. All right. So let me just stop that and put that down for a while. So I think the thing to point out here is, or thing to worth remember is, everything's a trade-off, right? And all these methods do have downsides. We've got separate tables, we have to do joins or not exist queries. I think the big drawback of this is probably just most surprising for a lot of people. If we've got null end dates, again, the problem here is we have to deal with nulls. But with mandatory end dates, we have magic values. And personally, I think magic values are just as bad, if not worse, than storing null. And you should absolutely try and just as hard to store magic values here. You know, here we've said the 31st of December, 1999 is means that date, but it also means infinite dates, the date we don't know, you know, well, we believe the customer lives there currently, or the row is still active. So I think you should still avoid these because they still need special handling. As we saw, if we want to find the last date someone moved out of an address or the maximum end date, you still got to have extra handling in your query, right? We haven't solved that problem entirely that nulls bring. And perhaps the bigger problem is it can be almost impossible to tell the difference between what is a real genuine value and what is a magic out of bounds value. I mean, it's pretty unlikely that you really need to store the value of 31st of December, 1999, but it's theoretically possible that there might be some contract or something which has that specific end date. And you just don't know. You just don't know what is different. Null certainly can mean multiple things, but at least it's more kind of bounded and context. So we know what's going on here. One thing I would say, whichever of these approaches you feel thinks best, never ever mix and match them within a table, right? So here we've got two active addresses, one which uses the magic value and one which uses null to represent this is, you know, where they currently live. Just don't do this. This is going to end up with a whole heap of pain. And of course, more generally as well, again, try and be consistent within an application. Like I say, personally, I prefer the null end dates rather than using the magic value. I think as much as there's downsides to null, the downsides of magic values are as big, if not bigger. But if I was working on a new application where people use 31st of December 1999 as the standard to represent current values, I would stick with that, because otherwise introducing my own pet methods just makes managing that application harder, right? So certainly never mix within a table, but also try and aim to stay consistent within the tables in an application. You might mix and match cross applications, but within an application, try and stay consistent. So, you know, they say that if you could try and do things like this, it can be very messy, right? See another comment. How about 21st of December, 2112? Lots of people imagine different magic, and standards get fun with different people doing revision and update tables. Yeah, I mean, I think the thing is, once you start getting into dates like 21st of December, 2112, I mean, that's far away, but it's not quite so far away that it's impossible. There's, you know, there's people who are born today who will probably live to see that date, right? So, or actually there's lots of people who live to see that date. It's only like 90 years in the future. So as soon as you start using magic values, you introduce your own problems, other problems. And I think one of the big things to remember here is no matter what you do to avoid null, no matter how you design your schema, you can't just put your head in the sand, pretend these do not exist. As relational databases, as they currently work, you are going to have to learn to deal with null values, even if you've made every single column in your database mandatory. So I'm going to run with three common examples where you're still going to encounter null in rough order of how common I think they are. So first up, outer joins, right? So we've got an outer join. Well, what values do we get for the columns of the child table if there's no matching row for the parent, right? Well, they're all null, right? And you might go, okay, well, we can prevent that. You know, we don't expect that, or we could solve that. If you don't expect there to be childless parents, you should just be a normal join. It should be an inner join rather than an outer join. So by writing an outer join, we're saying we expect there to be parent rows with no matching child, and therefore there are going to be null values in the result, right? And this is just kind of unavoidable in databases as they work today. Another really common example is adding columns to a new table. So by default, they are nullable. And the really interesting question here is, well, what value do we provide for those existing columns? If we want to provide a value, what do we set it to? In a lot of cases, you won't have a suitable default, or maybe you can add the column and derive it and run an update afterwards to set it. But in general, you know, there's not always going to be a way to actually set a reasonable default value if it is a new column. So this is another common situation where once you've added it, all historic data will have null, and quite often there's not much you can do to avoid that. Another common situation, this is analytic or window functions. So here I've got lag. By default, get the value from the previous row in the data set. What happens when we're on the first row in the group? Well, you know, we're going back to nothing. There's nothing before the first, so it's going to return null. Okay, so there are lots of situations, even if every column in your database is mandatory, where you are still going to have encounter null values and have to deal with them. So I'm going to show some more examples of these and see some other comments flying by. Just like programmers in the 60s didn't envision their programs would still be used in 1999, only 2 digits. Yes, very good point. I think as well, you know, as much as programs we write today probably won't exist in the year 9999, so what, 8,000 years from now, there's a chance, right? There's still possible. It's unlikely, but I suspect there might still be a few. Yes. So let's run through some of these examples. So we saw left join. There are, in the HR schema, there are some departments with no employees. Not quite sure why, maybe just prove the point. And we can see all those columns are null. And this has some interesting consequences. One is quite often you want to group by some value and count the rows, how many we're getting. If we do a count star returns the number of rows in the group, right? And there's always at least one row in each group. So the count always returns 1. It is 1 for all the rows. If you are outer joining and counting the rows in each group, it's very, very likely you want to count a column from the child table, the inner table, right? So the table you are outer joining to. Here are the employees. So if we want to know the number of employees in each department, we need to count a column from the employees table, not count star. I mean, there might be some cases where you want to do count star, but it's probably not that common, right? So something to be aware of when we talked about count earlier. Moving on, looking at those window functions. So there's only one employee in this department. So lag and lead will both return null because there's no row either side of it. And we're saying the average of the previous 10 hires. So again, excluding the current row from the output. So those values are all null. Now, the nice thing about lag and lead is they actually have some extra parameters. So the next one is how many rows to look forward or back. The final one is a magic value you can supply when you go beyond the data set. So we can return 0 when we go beyond the data set. So this can be quite useful to distinguish between there is a previous row and its value is null, and we are at the start of the group and there is no previous row. So this could be useful in some cases. Whereas with average and sum and so on, there is no actual clause here to say what to return if we've specified a window which goes beyond the data set, right? So in those cases, we'll need to map null to a real value. For numbers, quite often that would be 0. And there's actually a whole stack of ways you can do this here. You know, I see I've got 5 ways: MVL, coalesce, MVL2, decode, and case. All right, and it's like, wow, it's getting on overload a little bit. So I'll talk about MVL and coalesce a bit more in a minute. But I think there's good use cases for using both of these. But MVL2 is saying, check this. If it's not null, return the second argument. If it is null, return the third. So in here, this does the same as what we've got. To be honest, I can't really think of good reasons to use MVL. Everything you could, MVL2, everything you could write using MVL2, you could do with one of these other things like a case expression, which is more obvious. You know, I always have to look up and check which way around, is it the second or third argument that's returned if the first is null. I mean, if you've got a good reason for MVL2 to use it, to prefer it to the other ones, I'd love to hear it, but personally, I can't think of a good argument. Decode. So this is a bit like case. It's saying, check this first argument and then say, is it equal to the second? If it is, return the third. And this is the else condition, essentially. And we can actually add more of them. So interestingly, this adds another little quirk or exception to the null handling rules. Decode is one of the cases where null values are considered equal, okay? So it's saying if this is null and that's null, we're saying they are in fact equal in this case, all right, okay? Then return null, so we can do decode. This logic in that decode is basically identical to this case. So like I say, I think generally I just prefer case. It's more logical, easier to read. If we need to start doing other stuff, other conditions in here, it's easier to expand. You know, if you're working on an application that's been around for a decade or more on Oracle database, you've almost certainly got some decodes in the code somewhere. But personally, of these three, I would almost always choose case. I don't really have a good reason for preferring MVL2 or decode. But MVL and coalesce, I think, are still worth actually using. It's still worth knowing that about. First up, coalesce. So coalesce is the ISO standard one, part of the SQL standard. And one of the neat things about it is you can actually pass many arguments to coalesce, and it will return the first not null of these. So here you see we got 3 columns, and we get the first of them that is not null. So we can see Stephen, he's got no commission or manager, but so we get his salary for that. If we look at everyone else with no commission, we get their manager ID, and we go down to the people who have got commission, coalesce returns that. So it's pretty rare you have multiple of these, but when you do, we want to return the first non-null on the list. But when you do, I think coalesce is just a bit more concise than the equivalent case expression. So, you know, just easier to use in that case. One thing to be aware of, though, quite often you might write queries like this. So we have optional search criteria. We're going to say, if someone has passed an employee ID, pull that employee's information up. Otherwise, check it's the current employee ID, essentially return all the rows in the table. So I'm just going to get the plan for this query, and we'll search for an employee. So notice, even though we are technically querying by primary key, the database is still doing a full table scan. It is not using that index, because in some cases this value could be null. So we're going to return all the rows in the table. So with coalesce, it won't use that index. But I'll just pin that. With MVL, the database can do something a little bit magical, a bit scary. It looks a bit scary and weird at first, but essentially it's kind of split it into 2 queries. It's saying one where the employee ID is, where the value that we're searching for is not null, and another where it is null, okay? And we can see we've got 2 separate things here. One uses an index and one doesn't. And notice, look at this last starts column for the full scan. It hasn't actually full scanned the employees table. We've passed a value for it, so it has used the index. So as much as coalesce seems to be advantageous, no, MVL does have a plan advantage, can help with some plans. There is another subtle thing to be aware of. Coalesce uses short circuiting. So it stops as soon as it hits a non-null value. So we can see 1 is not null. So it never executes 1 divided by 0. MVL, on the other hand, always evaluates both arguments. So we get the divide by 0 error in this case. Important to be aware of if this second thing is a function or complicated expression. Think about do you really want to execute this in the cases where the first one is not null. So there are some differences between MVL and Coalesce, and both have use cases, situations where you may want to use them. For other types of mapping, I think you would want to stick with case. All right. One last example I wanted to show you before we wrap up. I see there's more comments been flying past. I'll look at those in a second. So this time, we want to find everyone with no commission, 0 commission. Here I want to find everyone with low commission. So we run this query. And as we saw, there's lots of people with null for commission. And this only returns those where the condition is true. So we're missing all those null, all those uncommissioned employees. And again, this is probably a classic beginner trap. Quite often, if you're asked to produce a report of all the employees with low or low commission, you want to include those people with no commission where it is null. So in those cases, there's lots of options you can do. You can do things like you can do or like this, separate it out. One thing I would say when using or is notice I've got these parentheses around it. Very important, because as we start adding, if we need to start adding more conditions to this, like higher date, whatever, very important we have those parentheses around to ensure we get the correct order of precedence for or versus and. So this can get a bit messy, can be easy to make a mistake, particularly if you've got a lot of these conditions in your query. So in those cases, you could do something, you could do MVL like this. We could do MVL, and this does the same thing, maps that to null, so we get all those null value commissions. Or there is one final option, which we could use here, and that is LNNVL, everyone's favorite function. Oh, maybe not. All right, LNNVL, what is this? It's logical not MVL. Okay, so notice I flipped the condition around. Instead of finding everyone who earns less than 0.2% commission, I'm searching for those where the commission is greater than or equal to. So this returns everything where this is not true. Now, not true includes unknown, so we get everyone with a null commission. Hey, awesome. Okay. All right. Okay. I'm still not sure there's many cases I would use this, but I think it's still worth knowing about. Primarily because this is actually used by the optimizer. You'll see some plans and they'll introduce this LNNVL operator to kind of exclude conditions for it. So it's useful to know what it is, just so it doesn't surprise you in cases where you actually see it. All right, if you've got any other questions, we're nearly on the hour. I see there's been more comments, loads of comments flying around, which is great. It's great to have some C getting involved in this. So let's see if there's anything worth addressing quickly before we wrap it. Does LNNVL use an index? As far as I know, it can do if we want it to. Let me just try create index. Can it use an index? I'm not sure. Certainly, yeah, we can't create an index on LNNVL itself. So we can't do that. It may be able to use an index on this column in some cases. I would need to check that. So I'm not entirely sure. Okay, so let's just see some of these other comments. What else is going on here? COBOL will still be around. Yes, I guess in 9999, COBOL probably will still be around. Can you explain what using is? All right, I'll just cover that quickly because I used it in my joins. Basically, it's just shorthand for department ID equals e.department ID. So instead of writing d.department ID equals e.department ID, it will automatically join on that for us. I've got a short video explaining it in more detail if you want to know more, but basically it just an equality join on that column or those columns. You can actually specify more of them. For PL SQL, there is an underscore parameter for making MVL use short-circuiting like coalesce. Yeah, that's interesting. I wouldn't go around setting underscore parameters, right? So, and I can't see that changing because, yeah, we see. Yeah, an index can't be created because Oracle still ignores Boolean values. Yes. Okay, let's see what else is there. I see there's more comments. All right, we're kind of past the hour, so actually I'll wrap up and then I'll come back to these in a second. All right, so just to kind of finish up, working with null, as we said, why does null exist? Well, there are several reasons for this. As I said, when Ted Codd came up with the relational model, he used null to represent missing or not applicable information. Now, that even if you manage to make all the columns in your database mandatory, you are still going to be null values in Oracle database and all relational database systems. It's still going to appear in things like outer joins, adding new columns, window functions where you go beyond the window. So there are lots of situations where you will need to deal with null. So how can we avoid it? Most importantly of all, do add the not null constraint to all the columns you can do. All right. Now you won't be able to do it on every column in every table, but you should be able to do it on a lot of them. Do not, this is one case where you really do not want to go with the default and allow optional values. If you know it's mandatory or you believe it to be mandatory, make it not null. If it turns out to be optional later, you can always modify it to remove that. As we saw, if you've got a column which is optional on a table, particularly if it's a group of columns, seriously consider splitting those out into their own tables. This now allows you, it's not going to be the right solution in all cases, but a lot of cases it can help a lot. Finally, when it comes to handling null, specifically if you want to find null valued rows, you need to use the is null or the is not null condition to find the opposite and understand and learn how those null functions work. Again, there's some quirks to several of them. Really just, to be honest, a lot of the time I just check the docs really, or try some things out to remind myself how they actually work. But I think the important thing is to be aware that they exist and know that they can help you manage and work with null values. Finally, if you want to get the scripts for this, they're on Live SQL. You can just go to this link. So you can run them in Live SQL. You can download them yourself to run in your own environment. Just uses the HR schema. So you can use that. I'm sure you can all get access to that. Like I say, I see there are more comments, so I will answer those in a second. But for now, all that's left to say is I really hope you enjoyed this. More importantly, I hope you learned something, and I'll see you next time.